Okay, hello, welcome everyone to this video of OpenFOAM. Let me just check the volume a little bit. Okay, it looks good. All right, so hopefully the volume's enough for you and there's not too much distraction. Okay, so last video, what did we do? Okay, we actually just tidied up bits of the equation in our experimental icofoam, or basically it's our ico heat foam. It's a classic ico heat foam file tutorial that we did before, and we know some basic syntax. Okay, we know some basic syntax. For example, what an include means, what a while loop is, what a return is, of course, int main blah blah blah. Okay, all of this is here for you. Now, one of the things is that if we want to learn how to program in OpenFOAM, we will need to understand what are the functions that are being used. For example, you see here runtime dot write. There's a function that's being used somewhere. Okay, it's obviously not in your normal C++. So one of these functions should be inside your foam name, your OpenFOAM, yeah, it should be inside one of your OpenFOAM files. You just don't know what OpenFOAM C++ files we are looking for. Okay, and if you keep looking at all of these, for example, fvCFD.H, piezo control H, post-process H, all of these, it will be very intimidating if you want to study each of these source codes just to understand what's going on. So unless you are really wanting to contribute to the source code full-time, it's not quite practical to study every single little bit of source code that's over here. Just let me demonstrate, for example, what this fvCFD.H is actually, where is it found and what are we doing? Okay, so if you go to the foam directory, if you're in your home directory, just type foam, it will bring you there. Or yeah, you just type foam and you'll be brought right to this foam directory where you see this all wmake. Now your solvers, your meshing tools will be inside these application files. Okay, so if you go to application, cd application, you will see these solvers, test tools, utilities. Okay, and that's where your icofoam, buoyant pimple foam, chi foam, whatever, all your solvers, the source code of each solver is there. Now when it comes to the include files, like where do you find this piezo control fvCFD.H? Okay, all of these will be found usually in the source code src. Okay, cd src. So these will contain all the libraries, all your libraries, and basically these are dependencies. Okay, so your solvers will use some bunch of functions over here, or which are encapsulated in some of these classes, and you just look at the number of classes there are. So if you want to study all of OpenFOAM, basically it's a full career for you. Yeah, and even those who are developing, they probably don't do it alone. They have a whole team of people working on the source code. So my long story short is, even for something like fvCFD.H, or you want to study bits of the OpenFOAM code, it's not quite practical. Alright, so yeah, I have not brought you to fvCFD.H. How do you find fvCFD.H? You can use this thing called grep-r. Okay, then you look for the pattern fvCFD.H. So grep is you find whatever, you find in the files, you look for a certain pattern in each of these files, and this pattern is called fvCFD.H. You can use the -r for recursive, which you search for folders, subfolders, and etc. Okay, you go for it, and good thing there aren't too many over here. And oh, right, I don't think I should use grep. Maybe, hold on, let me use another Okay, grep was not good. It did not fulfill the purpose you wanted. It will search for a certain pattern in each file. I think that the better thing is called find. Okay, fvCFD.H. Okay, oh no. Okay, so this is the correct syntax. I think I might forget. Alright, the basic syntax is as follows. Find in a certain path, look for a name, and then you look for this thing called file name. Okay, so let's do that. Okay, in the source directory, I want to find fvCFD.H. So let's do find. I want to put in this directory, use the name and fvCFD.H. Okay, so where will you find it? You will find it in the finite volume, CFD tools, general, include fvCFD.H. Okay, so let's go to finite volume, CFD tools. And you go to general and go to include. That's cat fvCFD.H. So this is where the file is right here. Okay, so you see fvCFD.H, even that has like 10-20 things going on. So again, we have our standard header loop. If not define fvCFD.H, define fvCFD.H, then the endif file is here. Then you have these includes. Include parallel run or parrun. I'm not sure. Okay, I'm not sure. I didn't study every single one of these. But you look at how many includes there are. Parrun, time, fvmesh, fvc, fvmatrices, fvm, linear, uniform dimension fields, calculated fvpatch fields, extrapolated, and so on and so forth. There's so many of these includes that are going on here. So this really, rather than including all of these header files individually, since they are used so common, they are included as fvCFD, finite volume CFD.H. Not only that, if for the reason we like to use the foam namespace, we have this if not define namespace foam, define namespace foam, and we use the namespace foam. So fvCFD.H already forces you to use the foam namespace. Okay, so if you remember what namespace is, for example, over here in our previous examples of basic code, classes, objects, namespaces. Okay, not here. Maybe I'll go to custom solvers and go to the dum-dum boy and pimple foam. I can show you, just to refresh your memory, what the namespace is. For example, if you want to use cout, you use the namespace std, standard namespace. And of course, the end line, you also need to use the standard namespace. Okay, so these namespaces will need to be used if you want to access these functions like cout and endline. Likewise, OpenFOAM has a whole whole collection of functions, okay, that you will need to use. Okay, OpenFOAM will have a whole array of functions that you will need to use. Now, of course, just telling you all of this may not be very helpful, because if you keep looking at solvers, you see how many includes files there are. This one's a buoyant pimple foam solver originally. The dum-dum buoyant pimple foam part, I just what do you call it? I just added a few lines of code to print some really dumb files. Okay, few lines of code. Okay, so if you want to really understand all of this, it's not quite possible. Okay, the other way of learning this programming practically is to actually just learn to use the functions. Just like you use MATLAB or Python, if you import some folder or import some series of functions, the functions are already there programmed for you. You just use them. Okay, you don't go and look at all the source code unless you really need to, which most of the time is unnecessary. Okay, you just use the source code. I mean, you just use the functions as is, and if you want to check if there are errors, you can go and use some other calculators. For example, there's a function to add 1 plus 1. You just use the function to add them. If you have functions for matrices, you just use those as is. Now, the idea probably with OpenFOAM is pretty much the same. So you cannot study every single bit of source code over here. You just use what's available and you learn what you need to learn as you go along. Okay, so what have we gone through so far? Hopefully, just to refresh your memory. Again, if you want, the source code is usually divided into a few places. Firstly, your application source code is usually in this applications directory. Okay, and all your, what do you call that? All your dependencies are usually located in this src file. Okay, and then if you have all these includes, yeah, you can tell the make file, okay, go and look for the includes there. So for example, if you go to your make folder, okay, experimental icofoam, you go to your make folder and you cat files, oh sorry, cat options. Okay, this is the OpenFOAM 2006 version. Okay, you cat options, you will see this. Okay, go to your source library file and please include this link includes. Okay, finite volume link includes. So let's go to source files, go to finite volume. Okay, so this is the other place you found your fvCFD.H. Go to link ln include. Okay, so you'll see all of these H and C files here. Okay, so these will all be, this is a directory where you can find your, if you type include something, the compiler GCC or G++ will look in this folder and you say, okay, let's look for fvCFD.H. So where's fvCFD.H? Okay, fvCFD.H is here. If you see this @ sign, this means it's a shortcut. Okay, so this is where all all your include files are, and they are kind of organized in a pretty nice manner. Okay, in the sense that okay, all your symbolic link. Okay, I think that's why they call it LN. Your symbolic link, LN, or your symbolic links are basically the other name for shortcuts. Okay, so in this folder, you'll find all your symbolic links to everything that's inside this finite volume directory. So all your C and H files are in this directory. So instead of specifying every single of these folders to go and look for these individual H and C files, you kind of put all the symbolic links inside this ln include. So that's an OpenFOAM style of doing things. So you do the same thing for mesh tools. Okay, so this is where you have your include files, and of course you have your libraries as well. I'm not going to go through this part. Okay, but at least you know where to find your files. Okay, so that's still a very far away. I mean, at least now we know where our application files are stored, where our dependencies, C++ dependencies are stored. So you will see all your C++ dependencies here. Just to give you an idea, all your C++ dependencies are usually here in OpenFOAM. These are the libraries or whatnot that you have, and yeah, you can basically learn to use these functions in these libraries with all the classes over here as is. Don't need to study all of them one by one, because it's pretty much impractical. So how do you study them? Okay, first, before I do anything, yeah, I just want to orient you to how to navigate the directories. Okay, so what I'm using here is the OpenFOAM user guide. This is also known as the API guide. Okay, if you Google OpenFOAM API guide, you will also land on this page. This is the API guide documentation. All right. If you go to home, you will look at this CFD documentation, blah, blah, blah. That's where we were just now. So remember, OpenFOAM API guide. If you cannot remember, I will just put this in the description below. Let me check how much time I have remaining. Well, 15 minutes in. Okay, so yeah, you can see it's not so straightforward. Yeah. Okay, so you take a look here. You, for example, you see these things, the double colons here. They refer to some namespace, right? So how do we actually help ourselves to go and take a look at these namespaces? Okay, if you open this directory here, you will see all of these what do you call that? All of these yeah, folders or open menus. Okay. Now, of course, there are lots of includes and namespaces and everything. So where do we start? Okay, we usually like to go to solvers, and where we were is incompressible icofoam. So again, go to solvers and go to icofoam. Just find icofoam from here, and over here you will be able to find some of the source code, icofoam source code. Okay, so this is where you'll find the GitHub or GitLab. This is GitLab. So at this point in time, this is GitLab. Okay, so if you go to this place here, you will, oh, this is the user guide. Sorry, I should be going to the API guide. Okay, let's go to the API guide. Okay, sorry. So you should be at the API guide, not the user guide. They are two very different things. User guide is kind of like documentation. API guide kind of tells you more about the structures and more into the C++ part. Okay, so forget what I said just now. You'll need to go to this place called namespace, and then you'll see what are the namespaces here. For example, the namespace form has all these functions, which I won't bother going through all of them. Okay, so this is where your namespace form is. Okay, if you kind of lose your side menu, just do some reload, it will help you. Now, of course, this is very difficult still. You cannot navigate. So let's go to something we are familiar with. Go to modules, and we'll go to solvers. Okay, remember, if we take a look at this OpenFOAM home directory, we will see applications in one folder, source code in another folder, and inside your application, you will see solvers, and I can ls solvers, and you will see all of these directories here. So like basic, combustion, incompressible, and compressible, etc., etc. So likewise, you will see under solvers, you have basic, combustion, compressible. So go straight to incompressible flow solvers and go for your icofoam.c. So this is where you'll find your icofoam.c, and make sure this is in the API guide, not the user guide. Okay, you can go to the source code of this file. It will bring you to this place here. Okay, so nothing that interesting, but if you see under icofoam, there are two files here. One is called create fields, one is called icofoam. So if you go to create fields.h, you will see something interesting here. Okay, application solvers, incompressible icofoam create fields.h. It is linked to this file called createfile.h. So you will see lots of these diagrams over here on the API guide. What does this mean? All this is saying, I think, it's this createfields.h. If you go to the source code of this file, okay, and under this source code, under this file, createfields.h, how is this code being read? Okay, you'll be reading some transport properties, for example, the dimension scalar new. Okay, and then you read the pressure directory. Okay, so this transport properties will be, you will check whether it's modified. You see this thing, IO object must read if modified. Okay, blah blah blah. Okay, never mind, I will not go through this part first. What I want to say is this: you will see this thing called include createfile.h. Okay, so that means that if createfile.h is missing, this whole code will go kaput. So in other words, what this piece of arrow what this arrow is saying is that applications, solvers, blah 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 is actually dependent on create_file.h. Okay, so what is create? If you want to go and look for what these files are dependent on, okay, you will need to navigate some of these arrow diagrams here. Okay, so for example, create_file.h. If you go and search for it, create_file.h is here, and let's just press enter. Let me reload. Create file. Okay. So you will see create_file.h, create_file.h. You just click one of these global namespace files. Okay. And then okay, maybe you go for the second bit. I'll go back a few lines. Create_file.h again. Go for the second global namespace. You'll see this thing called create_file.h, file reference. Okay, so you see this thing called file reference. Okay, file reference is pretty important. Why is it important? Because it will show you how to navigate your foam directory. Okay, you can see so many solvers are so-called dependent on this create_file.h. Okay, so if you look at all of these files, you can see where all the includes are from. So based on what we studied just now, we can say that this create_fields.h in uncoupled kinematic parcel foam, blah blah blah, it has an include of this create_file.h. So that will show you some of the dependency directories. Okay, all of these are dependent on this file. So if the arrow is pointing to this create_file.h, it means that these files are, they kind of use this as an include. Okay, so what are some of the files that we were looking at just now that kind of confused us? Or maybe what are some of these files? Okay, so for example, fvCFD.H. Okay, let's look for fvCFD.H and let's see if we can find some of these maps. Okay, fvCFD.H, and we can see that okay, a lot of these a lot of things are actually dependent. Okay, a lot of things are dependent on fvCFD.H, and fvCFD.H is in turn dependent on all these files. Remember, we were using the what do you call it? We were using the we were how do you say? We were listing the contents of this fvCFD.H, and we saw lots of all of these includes. Okay, and with those includes, you will see one arrow to each of these includes. Okay, so these are very important. And how then do we? Oh my goodness, I apologize for all the clicking, but yeah, this is what you need to do to navigate around. Okay, so there's another graph here. It shows files directly or indirectly included in this file. So these are some of these direct files here. Okay, and of course this guide will tell you, just now we saw what it defined, namespace.foam. It is actually listed under the macros thing here, and this macro definition documentation. Okay, I define namespace.foam at line 33 of fvCFD.H, just like what we saw just now. Okay, so enough of that. Let's go. I wonder if they have a proper scroll bar there. Oh my goodness. All right, let's go one of these things, maybe fvmatrices.h or fvm.h, right? Let's go and click on this, and you can see fvm.h is in turn dependent on all of these files here. Okay, so if you keep going down the rabbit hole, so to speak, for example, the divergence file, you will see that these divergence files are in turn dependent on volume fields and surface fields. These volume fields are in turn dependent on field types. These field types are in turn dependent on scalar. I mean, you can go on and on and on. You can go to float scalar, you can go to word, okay, you can go down to string, you can go to hasher, Okay, you can go all the way down, and you can see this is how you sort of navigate the whole batch of includes. Now again, I'm not showing you this to let you know where every single file is, because at this point in time I really don't know. But what I'm saying is that, you know, how can you navigate your includes in the C++ directory in a visual manner? Okay. Okay, one of the ways is to look at this file reference under the OpenFOAM API guide. So whenever you see all of these arrows, it means that, okay, this file is actually including one of these header files, the H files. Okay, so I think that's enough for this video. It's still quite a lot. Yeah, what I'm saying here is that if you want to navigate your OpenFOAM directory, okay, in general there are a few handles you can go for. Your applications will contain all your high-level source codes, meaning to say that they will have a lot of include files. And then where are all your include files located? All your underlying code that you kind of don't want to see, they are located in this source folder. Now there's a lot more to cover, so hang in there. All right, hang in there. So again, I'm just bringing you around how this OpenFOAM code is structured, how to navigate all of this using the OpenFOAM API guide. Of course, if you use the versions other than the ESI version, you can look in, they should have similar guides as well. Okay, but I will not go through some of those. I'll go through mainly the ESI version or ESI branch. Alright, so that's all I have for you. For this video, let's go and take a break, let your brain rest a bit, and then we'll continue up again.